Hello students, today we are going to learn about trigonometric ratio for some specific angle. Till now you have learned how to find out the ratio using SOHCAHTOA, right? Where here when the ratio is given, how do you find out the ratio of other trigonometric ratio? But here it's written for specific angle. So you know that we find out the trigonometric ratio for acute angle. So those specific angle, because calculator is not allowed in your exam, so that is why you have to remember this. So how do we derive these angles? So those angles, specific angles, are for those trigonometric ratios are going to be 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. So for these angles you will find out how do we calculate sine 0, sine 30, sine 45, sine 60, sine 90. Similarly for cos of all these five acute angles. Then you will find out here acute angle and the right angle, and then tan of these angles. How are you going to find out? So there is a derivation also. Sometime in the exam they ask the derivation. So let us see here. First we are going to take 45 degree, and how do we find out the ratio, trigonometric ratio of 45 degree? Now first when we start here, so we will take here, we will see here trigonometric ratio, ratios for 45 degree angle. So let us start with making right triangle. You know that we are having here, if I am having right triangle, I should have one of the angle as 45 degree. So you know that in a right triangle, what is fixed here? 90 degree place is fixed. And if I am having another angle as 45 degree, then the third angle is also going to be 35 degree. If I write on this as ABC, and if I mark this angle as 45 degrees, so here angle B is 90 degree, right? In triangle ABC, you can see angle B is 90 degree, and I have taken, because I need to calculate the trigonometric ratios of 45 degrees, so I have taken angle C as 45 degrees. So automatically angle A is also going to be 45 degree using angle sum property. So which kind of triangle is this? This is going to be an isosceles triangle, right? In isosceles triangle, if I need to prove, what we need to find out here? 45 degrees. So either you consider angle A or angle C for trigonometric ratio, you will get it. So how do we start? We will take here, let AB is equals to BC, because it's an isosceles triangle, is equals to x units. So let us mark x. Now using Pythagoras theorem, we will have AC square is equals to AB square plus BC square. Why we are doing it? Because to find out the ratio, we should have the length of all three sides. Earlier in the earlier questions, you were having numerical values, so you were getting the third unknown side. Here everything is in terms of variable. So let us find out AC in terms of x, which is going to be root 2x square, which can be written as root 2x. So mark here AC is nothing but root 2x. You got this value. Now how do we find out here trigonometric ratio? Now I am having all the three lengths, all the three sides length of this triangle. So first let us start with sine 45 degrees. Now sine 45 means if I am taking here angle C, which is sine 45, opposite by hypotenuse, which is AB by AC. Now what is the length of AB? X by root 2x. X gets cancelled, so you are left with 1 by root 2. So what is this is your first angle. So your sine 45 value is a constant which is fixed, 1 by root 2. Did you get this? Now similarly you can find out the trigonometric ratio of cos 45. It is adjacent side is BC by AC, which is x by root 2x. X gets cancelled, we are left with 1 by root 2. So you can see that here cos 45 is also 1 by root 2, correct? Now what is the third trigonometric ratio here? We take it, the basic trigonometric ratio is tan 45. Tan is opposite by adjacent. So AB by BC, which is x by x, and the value is 1. So we got all three basic trigonometric ratios here. The value of 45 degrees, sine 45, cos 45, the both are the equal values, 1 by root 2, and the tan 45 is 1. Now you will see tan 45 in your next application based question. This value is very important, right? So this is the derivation, because sometimes they ask now how to find out the reciprocals, because we need to find out here cosec 45 also. Now cosec 45, you all know that cosec is the reciprocal of sine. So here 1 by sine 45, you can just take the reciprocal of 1 by root 2, which is going to be root 2. Then here sec 45, if I take it here, sec 45, which is the reciprocal of cos 45, that value is also going to be root 2. And cot 45 is reciprocal of tan. So we'll get here reciprocal of 1 is 1. So all these six values, you have to remember only these three basic values for cosec, sec and tan. You can just take the reciprocal of sine, cos and tan. So hope you got this. Now what is the next ratio we got for your 45 degree? Now 30 degree and 60 degree. Now we will see here we have to take a right triangle, right? Now right triangle, how do you get it? Because 45 degree was very easy. You know that it can be isosceles right triangle. But 30 or 60 degree angle you see only in equilateral triangle, right? So here we'll take trigonometric ratio, trigonometric ratios for 30 degree and 60 degree. These two goes together, because if I am considering equilateral triangle, now equilateral triangle, if I take it, I don't see 90 degree angle here, and I need 90 degree angle because I can apply trigonometric ratios only for right triangle. Now using this, so let us start with triangle ABC. So here you will start with triangle ABC, which is an equilateral triangle. So here triangle ABC is an equilateral triangle. Right? Equilateral, how can I mark here? It's a equilateral. This side is equals to this side is equals to this side. Now you know that the construction is required here. In the construction, you can draw the perpendicular from AC to BC, which is going to be perpendicular bisector. Right, so here if I take, this is perpendicular and this is the bisector of BC. So what is the next one? You will take it here, draw AD. If I mark it as AD as perpendicular bisector of BC, right? So how are you going to start proving now? You know that each of the angle in equilateral triangle is 60 degree. So this is the complete angle. Can I mark here 60 degree? This angle is also 60 degree. Now, how do I find out 30 degree? For 30 degree, you have to show that here triangle ABD is congruent to triangle ACD. You can see that these two sides are equal. AD is the common side and BD is equals to CD. So using here SSS congruency. Why are we using here congruency? Because until unless we have congruent, then we can't get BAD. Angle BAD will be equals to angle CAD by CPCT, because corresponding parts of congruent triangles are always equal. So therefore it is angle BAD is equals to angle CAD, which is going to be half of angle BAC, and angle BAC is 60 degrees. So these two angles are going to be 30 degrees. So we got our 90 degree triangle here, 30 degree and 60 degree, right? So which triangle you are going to consider? Either one. Either you can take here triangle ABD or triangle ACD. I am considering triangle ABD. Now in ABD, angle ADB is 90 degrees. So we can use our trigonometric ratio, but none of the sides are known. How I am going to find out the trigonometric ratios of 30 and 60 degree? So let us start with let your all the three sides are equal. So AB is equals to BC is equals to AC is equals to 2x. Why am I not taking x? Because if I take x, then BD will be half of x. Then you can take x also, but here I am taking 2x so that I don't get the fractional value. Each value is x and x, right? So here again, how can we use here Pythagoras theorem? If I want to use Pythagoras theorem in this, so here BD is going to be equals to x units. Now here the side opposite to 90 degree is hypotenuse. So AB square is equals to AD square plus BD square. What is your AB? It's 2x whole square equals to AD is unknown. So let AD be AD plus BD is x square. Now 2x whole square, if you will see, it's a 4x square minus x square is equals to AD square. So you get AD square is 3x square. So how do we get AD? AD value is under root 3x square, which is root 3x units, right? So you can mark here x as AD, you got it as root 3x. So here I can take here root 3x. Now I'm having all the three sides, length of all three sides AB, BD and AD in terms of x. Now how are we going to use this? Now I know what is trigonometric ratio. Using SOHCAHTOA I can find out all these ratios. Sine 30. So let us continue with this. This is your triangle, right? So let us start first. So you have to consider triangle ABD. In triangle ABD, first let us find out all 30-degree angles. So here if you take 30-degree angles, so first thing, sine 30. Sine is SOHCAHTOA. Always remember this. It will give you the correct ratio. It is opposite by hypotenuse. For with respect to 30 degree, see this is your 30 degree. The side here it is hypotenuse. This is your adjacent and opposite is going to be BD. Right, identifying what is opposite, adjacent and hypotenuse are the most important part. So first sine 30, it is going to be BD by AB. Now what is the length of BD? X units by 2x. If I cancel, you are getting the value as half. So what is your sine 30? Here you can write down final answer. Sine 30 is half. This is your first trigonometric ratio for 30 degree. What is going to be the second one here? If I take here cos 30 degree. Now cos 30 degree, it is adjacent. Adjacent side with respect to 30 degree, it is AD by AB and AD is root 3x by AB is 2x. So x gets cancelled. You are left with root 3 by 2. So here if I take cos 30 degree, it is root 3 by 2. Right. Now similarly for the third angle, if I consider here tan 30 degree. Tan 30 degree, it is tan 30, it is opposite by adjacent, so opposite side is BD, adjacent side is AD and BD value is x by root 3x. X gets cancelled, the value is 1 by root 3, that is why tan 30 is 1 by root 3, right? And all the reciprocals we are not discussing here because you can just reciprocate sine 30 to get cosec 30 and to for sec 30 you can reciprocate cos 30, for cot 30 you can reciprocate tan 30, right? So this is for 30 degree. Now what are the remaining angles? You have to take it here. You have to find out now 60 degree. What is going to be a sine 60 degree angle? So let us see here. sine 60. Now again sine is nothing but now your 60 degree is the acute angle. See, there are two acute angles. We are finding ratios for both the acute angle. For sine 60, hypotenuse place is fixed. This is adjacent. This becomes opposite, right? This is opposite side. So how are we going to write on here? Sine 60 is opposite side with respect to 60 degree angle is AD and AB is the hypotenuse. So AD length is root 3x by AB length is 2x. X gets cancelled, root 3 by 2. So what is your sine 60 value? Now these values are fixed because you are getting a constant value and you need to remember these values to solve the question. Let us see the next one, which is cos 60 degrees. Cos is adjacent by hypotenuse with respect to 60 degree. Adjacent is BD by AB. Now BD length is x by AB length is 2x. X gets cancelled 1 by 2. So your cos 60 degree is 1 by 2. Right? Now when they say that, they will just give you proof that verify the value of these 30 degree, 60 degree. So you need to get all these values. And here tan 60 degree, tan is opposite. 60 degree opposite is AD by BD, which is AD is root 3x by x gets cancelled, the value is root 3. So here tan 60 is nothing but root 3. Did you get all these values here? So these basic values of 30 and 60 degrees are very important. We have already seen here for 45 degrees. Now what are the other angles? We said that there are 5 specific angles. We have seen for 30, 45 and 60 degree. Most of the questions will be based on this, but 0 degree and 90 degrees are important. Now you'll have a question, how can we in a triangle, because sum of 3 angle is always 180 degree. How one of the angle can be 0 degree or 90 degree, right? So here the next part is trigonometric ratios values. Trigonometric ratios for 0 degree and 90 degree. The proving part you get it for 30, 45 and 60 degree, but this you should be aware as this because you will have sometime the questions based on MCQ, multiple choice question or other question based on 0 and 90 degree also. Now first you have to understand, if I am having a triangle, if this is my right triangle, right? So how do I get 0 degree here? Now if I'm talking about here angle, triangle ABC, where angle C is acute angle, right? Now for C to become 0, the angle has to be decreasing. This rotation has to decrease. The angle has to decrease and this length CA, AC length will come on BC. So I'll show you here one figure. You will understand how to do it. Let us see here. This is, if you will see this picture is showing that, this image is showing that how gradually angle A is becoming 0. You can see that here. First, this is an acute angle. Then this angle is decreasing, right? The initial position was this. So it keeps decreasing here. So you can see the rotation is decreasing and at the end AC will fall on AB. So whenever here, we'll write on here if angle A is 0 degree, right? So what is this first here? This is your hypotenuse, this is your adjacent, this is your opposite with respect to angle C. So now angle A has to become 0 degree, correct? So what will happen here? BC length is decreasing till 0. So you should know BC has become 0 and AB has become equals to AC, because see at the end AC falls on AB. So these two length has become equal and BC has decreased and it has become 0. Now let us, it's 0, It's already there. So take the initial triangle, write down here what is going to be here, your sine 0. Sine 0 is going to be opposite by hypotenuse. Now BC length you already having 0 by AC. 0 divided by anything, it is 0. So sine 0 is 0. Similarly, if I consider here cos 0, what will happen to cos 0? It is adjacent, which is AB by AC. AB length has become equals to AC, so I can substitute in place of AB AC, and this is nothing but 1. So cos 0 is 1. These are the values you have to remember. And after that, if I take tan 0, then here tan 0 is opposite by adjacent, so BC by AB. Now BC value is 0, so 0 divided by AB, it is going to be 0. So tan 0 is also 0, right? So this is all the values you can find out. It's reciprocal also. Now what will happen? How do I identify? When do we get? This is for 0 degree. So angle A rotation is becoming 0. Now what will happen if I want 90 degree? In 90 degree, if you will see here, this is for if angle A has to be 90 degree. This is the another part. Angle A has to be 90 degree means your right angle. How will it happen? If I'm writing this triangle, again this angle A is has to become 90 degree. That means it has to come close to this because this is the rotation. If it will keep coming near to BC, at the end it is going to be 90 degree. So how do we see here? Let us see how this work. How does this work? Let us see here. Look at here, the ABC triangle is the initial triangle and slowly A is going near to B, right? So this angle at the end will become 90 degree because AC and BC are perpendicular on each other, right? So here what is happening here now, which length has become 0? This is again with respect to angle A, this is adjacent, this is opposite, this is hypotenuse. Then what is happening here? What is happening to AB length? It has become 0 and BC has become equals to AC. This you will understand, then automatically you will get it. Now write down all the trigonometric ratios. Here the first one, if I am taking here sine 90. So just check the first triangle, you will understand. Sine 90 is opposite by hypotenuse. Opposite BC length is equals to AC. So either AC, which is 1. So sine 90 degree is 1. Right? Similarly, let us take the second one here. If I take cos 90, it is adjacent, which is AB by AC. Now AB has become 0. So this is also 0 divided by anything, which is 0. So your cos 90 is 0. Similarly, if I take the third angle, tan 90. Tan 90 is opposite by adjacent. So it is BC by adjacent side is AB. BC has become, BC is AC or BC. So write down BC. Now here BC divided by 0, you know that it is always not defined, right? Not defined, it's infinity. So what is your third angle? Tan 90. Tan 90 has become infinite or not defined value. Tan 90 is not defined because 0 divisor 0 is not possible. You get not defined value. So these are the basic values you should know. Now sometime here if you will see, if I would like, because tan also using sine and cos you can identify. How do we take it? Let me first take any triangle here. Why do we say, if you will see this result, tan theta is always equals to sine theta by cos theta. Why this is true? Remember, this is important result. Okay, now here, how can I show that? Let us see one right triangle, then you will understand why, how can I write down this, right? So this is, if I am writing here triangle ABC, right? and the angle is theta. So how can we write down here this angle? If I take it as theta, you know that sine theta is opposite by hypotenuse. So is it AB by AC? And cos theta is nothing but adjacent by hypotenuse, which is ABC by AC, and tan theta is AB by BC. Now, how do I relate sine, cos, and tan? If I see, because I told you already sine by cos is tan. So, how can we reach to that result? If I am taking here sine theta divided by cos theta, so their RHS also will be divided, right? AB by AC divided by BC by AC. Now divisor, it's a fractional form. You can reciprocate into AC by BC. This gets cancelled and you reach to AB by BC. Now AB by BC, it's nothing but tan theta, right? So tan theta, this is the important result. You should all remember tan theta is always equals to sine theta by cos theta. It's very important to remember the rules, right? So we got individual all the values, but sometimes see you are not going to derive while solving the questions. You are going to remember all these values. So how do we remember? Because while solving this, you know, it's looking very lengthy, but there is a trick to remember it. Let me take one table and I'll show you how can you remember. If you remember for sine, you can find out the values of all cos and tan, and once you have sine, cos and tan, you can find out all the other trigonometric ratios for the specific angle. Now this is my tabular form. I have not written here cosec, sec and chord because that are those are reciprocal of these three angles. Now I'll tell you here, that is a trick to remember because we already got the values. Remember sine here, if I take here sine theta for 0 degree, 30 degree, 45 degrees, 60 degrees and 90 degrees. I can write down this value as first because it's 0, 0 by 4. This is root. This is the trick to remember these values. Okay. I would say you all should remember these values, but if you don't remember initially, you can use this. But slowly, when you will start solving questions, you will remember it. It will be in your muscle memory. So 0 by 4 is 0 degree, sine 0. Sine 30 is 1 by 4. Then sine 45 is 2 by root 2 by 4. Sine 60 is root 3 by 4. Sine 90 is 4 by 4. Now, if I do this simplification, this is 0. Now root 1 by 4, will it be 1 by 2? Then this is nothing but 1 by 2, which can be written as 1 by root 2. Root 1 by 2 is 1 by root 2. Then this is, what is this value? Root 3 by 2, and this value is 1. And if you will see, if sine 0 is always 0, I can show you here. You already got it here. See, sine 90 is 1 and sine 0 is 0. So first sine 90, it is 1. See, using this rule also we are getting here 1. Can you see? Then here 30 is root 1 by 4. Wherever you got here 30 and 60 degree, you can see that here sine 30 is 1 by 2, sine 60 is root 3 by 2. So I can take it here, and using these roots also you are getting the same value. This is 1 by 2, this is root 3 by 2, and this is 1 by root 2. Right? If you remember these rules, right? So you will see that sine 0 to 90 degrees, the value is increasing. 0 is less than half, half is less than 1 by root 2, which is less than root 3 by 2, and that is less than 1. Right? So it's always sine 0 to 90 degree value is increasing, whereas cos 0 to 90 degree the values are decreasing. Now you can change the order. Sine 90 is cos 0, which is going to be 1, right? Similarly here, sine 0 is cos 90, which is 0. Why does this happen? Because in the right triangle, if I take one of this angle ABC, if I take this as 30 degree, then this angle becomes 60 degree. So whatever is cos, if I'm writing here, you can check here also. Look at here. This is sine 30 is AB by AC, and cos 60 if I take, that is also cos 60 is also AB by AC. So these are complementary angle. 30 and 60 makes 90-degree angle, right? So whatever, so you can take it in a cross way. So here sine 30 is half, that is going to be cos 60, which is half, right? And sine 60 is root 3 by 2. So this is here 1 by 2. Sine 60 is root 3 by 2. Similarly, cos 30 is also root 3 by 2. And this is the common value because 45 degree, it is 1 by 2. Correct? Now tan, if you don't remember tan values, you can just do here. If I'm taking here, it is tan theta is sine theta by cos theta. So you can divide also. I can divide these two to reach to tan theta. How are you going to do it? Tan 0 is 0 by 1. If I take 0 by 1, that is 0. 1 by 2 divided by root 3 by 2, it is 1 by root 3. 1 by 2 by 1 by 2, it is 1. Then root 3 by 2 divided by 1 by 2, it is going to be this, and this is going to be not defined value, right? So hope so remember these, and here also tan 0 to 90 degree is also increasing. Sometime in multiple choice question they ask these kind of questions. Sine 0 to 90 degree, it's always increasing value, so you should remember this is increasing. Cos 0 to 90 degree, it is always decreasing value, and tan 0 to 90 degree, it is always increasing value. Hope you got this. You have understood this. How do we use, we have to, how do we identify, how do we find out the trigonometric ratios of these specific angles. So thank you. Have a good day. Take care.
Thank you for watching this video. Please like, share and subscribe. Also, keep practicing.